started with lesson 2. This is workbook page 25, and I just want you to take a minute to look at this page and see if whether or not you agree with Maya. She predicts that the graph of x plus y equals 6 looks like this. Do you agree? Explain. So pause the video here and take a minute to write down on page 25 whether or not you agree with Maya. All right, now that you've decided whether or not you agree, let's take a look at what we are doing when we are actually graphing an equation in two variables onto a coordinate plane. So we already do have some points here. Our equation is still x plus y equals 6. So let's start by checking some of these points. So first we're going to start with checking this point. And this is the point for 2, right? If I were to write my coordinates out, it would look like this, where my x is 4 and my y is 2. So let's check that out. Oops, I didn't mean to make that big 4. If my x is 4, I'm going to put that value into my equation for x. So 4 plus y, this equation is saying has to equal 6. Obviously, 4 plus 2 is 6, so that means that this point, right, 4, 2, is a point on this line. So you can go ahead and check some of these other points. They're already done for you, but also see if you can try any others. Like what about if x is a negative number? What if we have x is, let me choose a different color here. What if we have x is negative 2? Well, I would do the same thing. I would put that value in for x into my equation. Negative 2 plus y equals 6. And here we are practicing solving equations, right? So if I were using a scrap piece of paper or a whiteboard, I could do my work to figure out what y is somewhere else. Remember, I want to get y alone, so I'm always going to be doing the opposite operation. In this case, I want to move the 2 to the other side. Since this is a negative 2, I'm going to add 2, which means on this side of the equation, I am left with y. Because I added 2 on the left, I need to add 2 on the right. 6 plus 2 is 8. So when x is negative 2, y is 8, and I can go ahead and graph that point as well. So try a few other points here before moving on to the next page. This is page 27, and we're doing the same thing. This time we're not given any points to start with. You're just going to go ahead and graph the equation. So I can choose anything I want for x or anything I want for y. I tend to choose an x. So I'm just going to pick something easy and random. What does this equation look like when x is 0? Well, I'm just going to put 0 into the equation. 3 times 0 plus y equals negative 8. Well, again, I'm going to be solving that equation, so let me rewrite it down here. Sorry if this is messy, I'm using my mouse. 3 times 0 plus y equals negative 8. And you don't have to choose 0, you can choose something else. I'm just showing you how this is done. So first, I'm going to combine like terms. 3 times 0 is 0. 0 plus y equals negative 8. Well, obviously, I don't really have to do anything to the 0 to get rid of it. I can just kind of erase it, pretend it's not there. Y equals negative 8. Okay, so now I can graph that point when x is 0. So I'm graphing the point, of course, 0, negative 8. So we're getting practice with solving equations here and also with graphing. So I'm going to go over 0, up, not up 8. That's negative 8. I'm going to go over 0, down 8, to place my point, my first point, at 0, -8. And it is a good idea to kind of write these points out as well, just so we can make sure we're graphing them correctly. Again, this was workbook page 27. For your work today, you are going to try a couple others. This problem on page 28 is the same. Just now you have a fraction, but you're still picking any number for x. You can make it an easy number. Make it 0, make it 1, make it -1, whatever you want. You're just graphing 2 points. The problem here on page 29 gives us a little bit of a different vocabulary. So let's talk about this problem on page 29. Use the table to find 2 ordered pairs that satisfy the equation 4x minus 3y equals 12. Then use the ordered pairs to graph the equation in the coordinate plane. So, actually, no, well, we can talk about it here, I guess. I thought this problem was going to ask us to use the intercepts, so that's what we will practice. The intercepts basically are where whatever line we end up with is going to cross both the y-axis, that would be the y-intercept, and the x-axis, that would be the x-intercept. So don't write this on your graph. So again, where that point crosses the y-axis is known as, actually I'm gonna type this instead of trying to. So this point, let's say this was my line, I would say that 5 is my y-intercept. And over here, whatever that point is, I can't really tell maybe where that landed. Maybe it's 5.5 or something, wherever it is. But that point, whatever it is, where my line crosses the x-axis is known as the x-intercept. So those two things are important. So if we're using the intercepts in order to graph this line, well, that means I want to know when x is 0 and when y is 0. So let's take a look and see what that looks like. I thought I could maybe erase these words, but I guess not. Oh, well. All right, let's see. So what does our line look like when x is 0? Well, I'm just going to put 0 into my equation. 4 times 0 minus 3y equals 12. Okay. So again, I'm going to start just by multiplying 4 times 0 together. That leaves me with 0 minus 3y equals 12. The 0 is already not there, right? I can just ignore it. So I need to now get my y alone. So I'm going to divide both sides by -3. That leaves me with y on this side. I'm going to divide 12 by -3, and that is -4. So when x is 0, y is -4. So that means I'm going to go over 0, down 4. And that is actually my y-intercept. So maybe I'll try to move these words down here. That is my y-intercept. When x is 0, y is 4, -4. -4 is the y-intercept of this line. And now I'm going to do the same thing. Well, what is my point when y is 0? So I'm going to rewrite the equation, but instead of putting the 0 in for x, I'm going to put it in for y. 3 times 0 equals 12. Okay, so same thing. I'm going to start off by doing 3 times 0, which is 0. So I'm left with 4x minus 0, which I don't really need, equals 12. Again, this minus 0 is not really there. So I'm left with 4x equals 12. In order to get my x alone, I want to divide both sides by 4. And I'm left with x equals 3. So when y is 0, x is 3. So let's go ahead and put that on the graph. So this time I'm going over 3, but up 0, and that point 3, or the number 3, the point over 3 up 0 is my x-intercept. So let me actually just put those points in that. This is the point 3, 0. 3 is my x-intercept. And this is the point 0, -4. And -4 is my y-intercept. So I will just type that in here as well. For this equation, 3 is the x-intercept and -4 is the y-intercept. So when we're talking about the intercepts, we're just talking about that particular number because we already know the other part of the coordinate is 0. So you are going to work on the practice problems here. This is workbook page 37. So try out these practice problems at least until page 39. So I am expecting that you can do page 37, page 38, and page 39. It is really good practice to get these x and y intercepts. And on page 40, you can graph them if you want, but if you're just putting 0 into the equation, you should be able to come up with your x and y intercept. So again, try workbook pages 37, 38, and 39, and then you're also going to do the exit ticket and turn that in today. Please let me know if you have any questions.